I want to introduce our guest today, Mark Laidlaw. Mark has agreed to be a part of our monthly soil lead presentation. My name is Dan Richter, and my colleague Kay Jowers is here, and we're going to host this presentation in a webinar fashion. So when we get to the question and answer period, if you look at the bottom of your screen, you can see a Q&A. And because it's a webinar, Mark and I will field those questions at the end of the talk. And we appreciate every one of you for joining us as we learn more and more month by month. We've got a great cast in front of us coming up of future presentations, and we'll continue to do it monthly. We did it today because Mark lives in Australia, and it's at 10 a.m. Eastern time, Eastern Daylight Time, New York City time. But for Mark, it is midnight, and for that, that's an incredible thing. You know, that's a load to bear. But I've enjoyed your enthusiasm so far, Mark, and willingness to do this. So Mark has worked with a variety of top-notch scientists over the years, published a number of papers. He works in environmental consulting these days in Australia, where quite a bit of soil lead work has been done in the past. Quite a bit of lead toxicity work that's very important worldwide has come out of Australia. And without any further ado, I introduce you, Mark Laidlaw, and thank you again for your talk today.
Well, thank you very much, Daniel. I really appreciate it. The title of my talk is Legacy Urban Soil and Dust Lead Contamination and Children's Blood Lead Seasonality. Is it the main driver of lead poisoning in America? So about me, I have a BS in geology from the University of Dayton, MS in geology from Indiana University, a PhD in environmental science from Macquarie University in Australia, and a postdoc at RMIT University in Australia. And I'm currently working as a contaminated lands environmental consultant in Sydney, Australia. So the main sources of lead in urban environments are soil from leaded gasoline, exterior lead paint, lead smelters, used lead acid battery recycling, and that's mostly in middle income and third world countries. House dust from lead paint particles and soil dust, water from lead and water lines, and airplanes from general aviation propeller planes. This is a plot of historical lead and gasoline and paints in the United States. It's from, the x-axis is from 1910 to 1990. And the blue line is, or in the y-axis is lead usage in tons times 1,000. So between about the 1930s and 1970, the lead usage increased exponentially. In the 1970s, they were emitting about 250,000 tons of lead from gasoline. And the lead and paint was mostly applied between at least 1910 and 1950. So all this lead that was emitted in the gasoline was emitted within approximately 50 meters on the roadside. And the lead paint that was applied on the exterior deteriorated into the underlying soil over the years. So there's approximately 2 grams of lead per gallon, and about 5 to 6 million metric tons of lead was used, and it became a lead dust source. There's up to 50% of paint is composed of lead, and up to 5 to 6 million metric tons is coating subject to dust. The background lead concentration in soils is typically about 20 to 30 milligrams per kilogram. This is a plot of soil lead concentration with distance from the roadway in Indianapolis, Indiana. The x-axis is from 10 to 45 meters away from the roadway. And the purple vertical columns are urban soil lead concentration. You can see it decreases with distance away from the roadway. And the blue column is suburban soil lead concentration. It also decreases with distance from the roadway. The soil lead concentration has been found to be proportional to historic traffic flow. This is a picture of flaking exterior lead-based paint. So this paint on the homes deteriorates and falls to the ground surface adjacent to the foundations of homes. And this is a plot of soil lead concentration with distance away from the house side on a number of houses in Boston. And you can see that the soil lead concentration is highest near the foundation, 1 to 3 feet, and decreases with distance. So this is a plot of a density estimation of soil lead concentration done by Laidlaw in Durham, North Carolina. And basically what they sampled over 1,000 sampling locations and found that the foundation soils had the highest concentration, which was greater than the street side, which was greater than the residential yard, it's greater than the floodplain, greater than the upland, and the new suburbs had the lowest soil lead concentrations. This is a plot of soil lead versus house age in Melbourne. On the x-axis, you can see, like on the left-hand side, is pre-1895 soil lead concentration, and on the far right is post-1975. You could see that as you go to the left side with older houses, you have higher soil lead concentration. And it's also been found in multiple studies that houses with exterior paint have higher soil lead concentration than brick homes. So this is a plot of soil lead concentrations versus depth in Indianapolis, Indiana, in an urban core and a soil core and a suburban soil core. You can see that the soil lead is primarily restricted to the top 20 centimeters. It also, it should be known that urban soil lead is highly bioavailable. Now, the soil lead bullseye, basically soil lead forms a bullseye pattern in urban areas internationally. It's highest in the urban inner city areas. This is a plot of soil lead concentration in New Orleans. You can see in the center there, the concentrations are as high as up to 1,000. And so it's basically highest in the inner city and decreases with distance away from the city center. The same pattern is found in Syracuse, New York. This is a plot of Indianapolis soil lead concentration. I don't know if you can see, but in the center, there's a red zone, and that's greater than 200 ppm lead. An orange zone is 125 to 200 ppm lead. And the yellow zone is 75 to 125 ppm lead. Now, each one of those dot points is a child with blood lead poisoning greater than 10 micrograms per deciliter. Now, this is only based on 8% of the population being tested. And these soil lead concentrations are actually low because they were collected in open areas like parks and Gabe Filippelli has gone back and looked at foundations, and they're much higher concentrations. This is a plot of New York City's soil lead map, and the red area is a concentration of 400 to 1200 parts per million, and 400 parts per million is the US EPA guideline level. And the yellow is 150 to 399, and green is 1 to 149. This is a plot of the Paris soil lead map, and you can see it's the same pattern as the other cities. Moscow, Russia, same thing. This is a plot of London, England, and you can see that they have really elevated soil lead concentrations in the center of the city with the historic traffic flow. This is Sydney, Australia. You can see that the area to the lower right is the Sydney CBD and the older areas of the city, and it decreases with distance away from the city center. This is a plot of soil lead concentration in Flint, Michigan. You can see that the red areas, you have a concentration 151 to 222 milligrams per kilogram, but same pattern. So how does lead in soil dust get into homes? Now, Postenbach reviewed the literature and found that 20 to 80% of house dust is composed of soil. So it should be easy to understand if you have exterior lead contaminated soil, that your house dust is going to have lead in it in high concentrations. So the lead gets into the homes through soil resuspension, shoes and boots, and pets' feet and fur. Now, soils become resuspended into the atmosphere when they are dry and wind speed is sufficient. This is a plot of the, it's called the Improve Air Monitoring Network. And this is a plot of atmospheric soil dust resuspension seasonality in 4 locations throughout America. And this is a long-term air monitoring program in the USA that began in 1985 to improve visibility. Atmospheric soil is estimated using a mineral equation based on elemental composition of soil. So at these air monitoring locations, they analyzed a variety of trace metals, and they're able to calculate or estimate the amount of soil in the monitoring samples. So this is a plot of atmospheric soil and lead seasonality in Detroit, Michigan. In what you can see, the time period is 2001 to 2009, and each one of these peaks is a separate year, and the height at the top of the peaks represents a time period in usually in July or August. And the red line is air lead, a medium spline, and the dashed line is air soil. And the data is represented in the points. And you can see that the soil and lead are highly correlated. And this is this was collected using an Improve Air Monitoring Station in Detroit. I believe it's an EPA air monitoring station in the Improve network. So what this paper found is that a 1% increase in the amount of resuspended soil results in a 0.39% increase in the concentration of lead in the atmosphere. So, excuse me. This is a plot of atmospheric soil dust and lead seasonality in Pittsburgh, Detroit, Chicago, and Birmingham. The same pattern that we had in Detroit in the previous slide is occurring with peaks in the summertime. You can see those vertical lines, those are the summertime. And yes, so this is, so basically the same situation is occurring. So the data was obtained from the improved air monitoring stations. This, this chart here just came out a week ago. It's from a study in PNAS. It's basically shows how roadside, let's see, basically this is a daily high resolution measurement of lead and silica beside the roadway. And this is over an average of over 7 days. Each one of those is a separate day. So lead and silica in the PM10 exhibit the same diurnal trend, with them peaking in the middle of the day and decreasing toward the night. It are also found that weekdays the lead and the silica are greater than weekends. And the reason they use silica is because it is a proxy for soil. So resuspension with high traffic is associated with higher airborne lead concentrations. So the same weekday, weekend observations by Laidlaw et al. In Pittsburgh, Detroit, Birmingham, and Chicago, which I showed you that previously on one of the soil and dust lead seasonality curves. So this strongly suggests that soil resuspension is a primary driver of atmospheric lead. So the urban, sorry, I'm having a hard time seeing the top. Urban atmospheric lead patterns, so they appear to show a diurnal pattern, a weekday, weekend pattern with lead higher on the weekdays. A seasonal pattern with lead highest during June, July, and August, and an overall declining trend of lead concentrations in the atmosphere. So now I want to talk about a Fivehouse study that I did in Sydney. It was a 15-month study. I chose 5 houses with a wide range of soil lead concentrations. There are brick homes, monthly vacuum bag and exterior dust gauge lead concentrations were measured. Quarterly interior and attic lead dust sampling was performed, and lead isotopes were analyzed on soil, paint, and vacuum bag dust, and synchrotron analysis of soil and vacuum bag dust. So this is a plot of Sydney's air lead deposition at the 5 dust gauges that were located at the rear of the 5 houses. And you can see on either end, it's higher and it's lower in the middle. Well, then the middle period is the winter in the Southern Hemisphere. And the summer period is December, January, and February. You can see it's much higher, the lead concentration. So the study also found a positive correlation between soil lead and exterior lead in the dust gauges. And it was more pronounced in the summertime, whereas in the winter, there wasn't really much of a relationship at all. So this showed that exterior soil lead influences house level air lead exposure. Also found a positive correlation between lead and soil and interior vacuum bag lead concentration. And this shows that the exterior soil lead and interior lead exposure are linked. Now, blood lead seasonality is the average monthly blood lead level of children in a city plotted over time. It has been observed to peak in the dry months. It typically peaks in August and September in the USA. The hypothesis about the cause over time have included dry period soil lead resuspension hypothesis, the vitamin D hypothesis, where changes in sunlight affect the bones and the release of lead from the bones, opening and closing of windows in the summertime, and lead leaching from pipes in the summertime. So whatever is controlling these curves, I argue, is the dominant lead exposure source in urban areas. This is a plot of child blood lead, 90th percentile of child blood lead levels between 1990 to 1993 in Milwaukee, Wisconsin. This is done by the US EPA. And the ages are a half to a year, 1 to 1.5 years, and 1 1/4 to 3 years. And you can see that they peak in July every year very regularly, and that they're also, it's declining with time. This is a plot of child blood lead seasonality in New York State. The y-axis is greater than 10 micrograms of lead per deciliter. And the time period is from 1995 to 1999. The orange line is 2-year-old children, and the red line is 1-year-old children. You can see that they peak in August, very regular, and they're declining similarly to the Wisconsin or the previous slide. This is a plot of a monthly average blood lead concentration in Milwaukee, Wisconsin between 1996 and 2008. You can clearly see that the blood lead levels peak in July, August, and September, and they decline towards December, where they have a trough in March. This is similar chart in Detroit, Michigan. No, this is for the state of Michigan. You can see the similar peak in July, August, and September, a trough in March and April. This is a plot of atmospheric lead and children's blood lead in Detroit from 2001 to 2009. The data was obtained from the improved air monitoring station in Detroit. Now you can see that the red line, this is from like 2001 to 2009. The red line you can see is the air lead, and that peaks every summer. And that's what they call that, the summer disease, it goes ahead and peaks in the summer. And you can see that the blood lead level for the children aged 1 to 2 years follows the exact same pattern as the air lead. And the aged 1 to 2 years are closer. They mimic the air lead more closely than the children aged 6 to 10 years. And that's likely due to because the children aged 1 to 2 years have the hand to mouth activity. So basically the seasonal soil dust is resuspended, causing elevated air lead, and then the air lead then poisons the children, resulting in elevated blood lead. So this blood lead data was obtained from 367,000 children from Detroit, Department of Community Health. So what this study found is a change of 0.0069 micrograms per cubic meter in atmospheric lead increases blood lead level of a child 1 year of age by 10%. This next plot is a plot of blood lead seasonality in the United States. The y-axis is number of cases of blood lead greater than 10 micrograms per deciliter. The x-axis is months of the year, and you can see the same pattern, you know, with July, August, September peak. So this is across the United States. So it's the dominant trend in children's blood lead. Okay, this is a plot of blood lead seasonality in Detroit, Michigan, or sorry, in the state of Michigan, and in Flint and in Genesee County. The y-axis is blood lead greater than 5 micrograms per deciliter. The percent blood lead greater than 5 micrograms per deciliter. And the x-axis is from 2001 to 2015. And if you look at the red line, you can see that it peaks in the third quarter every year. So that's the blood lead. And the green line is for Flint, and it showed the same peaks as the red line. But you can see that right after the Flint, starting the Flint River water, the levels went up much higher in third quarter of 2014 and the third quarter of 2015. So children's blood seasonality correlates with atmospheric soil dust, atmospheric lead, PM 2.5, and the dry time of the year. There's also a lot of other blood lead seasonality plots that I have not included, but they're at the back of this presentation, which if you want to go onto my ResearchGate, you can go ahead and look at those. So blood lead levels have been steadily declining over time. The chart to the upper left shows New York State. The upper right says Michigan and Flint, and the one at the bottom is Wisconsin, I believe. Yeah, Milwaukee. So you can see that they're all declining gradually over time. Milky, Howard Milky did a study where he looked at soil lead and blood lead measured in 272 census tracts that were taken about 15 years apart. And he found that the soil lead median decline was about 2.4 milligrams per kilogram per year. And the median decline of children's blood lead was about 0.2 micrograms per deciliter per year. Milky also did a study in the Tri-County area of Michigan. He analyzed soil lead concentrations in 8 Detroit Tri-County area census tracts, and he repeated that in 2019. What he found is that Detroit's median soil lead decreased from 183 to 92 milligrams per kilogram over that time period from 2002 to 2019, or about 5.4 milligrams per kilogram per year. And in Pontiac, it decreased from 93 to 68 milligrams per kilogram, or about 1.4 milligrams per kilogram per year. Also, children with blood lead greater than 4.5 micrograms per deciliter in Detroit declined from 44% to 5% during that time period, and in Pontiac from 17% to 2%. The weighted it all made the argument that there are multiple reasons for the declining soil lead that has been observed. One is erosion, cut and fill, sediment deposition bearing soils, the translocation, like migration to deeper depths and transformations. And I've also added this is that resuspension and deposition of lead in soil onto impervious surfaces and flushing out to water courses could also be a cause of declining soil lead concentrations. These are two plots of the spatial relationship between blood lead and soil lead. The one on the chart on the left is the Detroit soil lead blood lead curve, and you can see that there appears to be a pretty good relationship. And the plot on the right is for New Orleans. So basically, as soil lead concentration increases, children's blood lead concentrations increase. This is a plot of children with blood lead greater than 10 micrograms per deciliter in Milwaukee, Wisconsin. And there were 36,856 children poisoned between 1996 and 2006. You can see that there's a high density and it's located in the inner city areas. This is the most shocking plot of all that I've seen of lead poisoning in America. Every dot is a Detroit child with lead poisoning. This is taken from 2001, and I think it was 16,776 children who had blood lead greater than 5 micrograms per deciliter. Anyways, okay, so this is a plot of blood lead concentration greater than 5 micrograms per deciliter in Cleveland, Ohio. And the average for Cleveland is 22% of the children have blood lead greater than 5 micrograms per deciliter. But you can see as some of these suburbs have much greater concentrations, such as 36 to 46% of the children having blood lead greater than 5 micrograms per deciliter. And these, you can see these are in the inner city areas, and a lot of them are African-American individuals. So the solutions to the problem, I think, I suggest that soil cap and isolation or excavation, especially near roadside soils, would be a good idea. Mulch covering exposed soils in gardens and flower bed to keep the soils from being exposed to children, and having soil resuspension. And irrigation, or just keeping lush lawns with that are moist to reduce the resuspension in the summer. And also encapsulating and remediating exterior flaking lead-based paint to stop the recontamination of underlying soil at the foundation. If you're interested in reading more about this, I wrote a literature review on this in 2017. So I think this what needs to happen next is large-scale remediation, pilot studies, and implementation. So why has remediation or more research been conducted? I think it's because one of it is because of the interior lead paint paradigm, where some people think that only the interior lead paint is the only cause. Low awareness of soil lead, no corporations to go after and get funding from. Governments don't seem to be interested. It's too hard. The problem is too extensive. There's no funding, a lack of concern for urban poor issue, and political weakness of urban poor in the USA, and environmental racism. Because I think that if this were to have occurred in white suburban areas, that there would have been more action. And so that's all I have. Thank you very much for putting up with all my ums and nervousness. My presentation is posted on my ResearchGate profile if you're interested in reading further. Thank you.
Mark, yes, thank you. Yes, we got a number of questions, and it was well timed. Quite a powerful presentation, we've got a half dozen questions already lined up. If you want to take another drink of your
okay, yeah,
your Diet Coke,
yeah,
as it approaches 1 a.m.
yeah,
in your hometown, you did a great job, and I really admire you for sticking with this problem for so many years. Yes, so we got an anonymous attendee as the first question. And it's a good question. Your population curves that showed blood lead is the topic of this question, the seasonality of blood lead. And the question is, are we necessarily looking at the same individuals over time in the multi-year plots? How about during different seasons within the year? Or would you say we can't tease that out from the data, but the curves show overall population exposures that are reasonably related to seasonality? Great question.
Yeah. I don't believe they're the same children over time. I don't really have the answer to that because there's, I don't have it in my head right now, but yeah, I think that, geez, I'm losing my train of thought.
So I've got a suggested answer, and I'm quite confident. I think these are aggregated population data across many kids. And to me, that represents a special power that these seasonal data show, that it is across the populations, although a more controlled experiment would be to monitor the same kids. Howard Milkey, want to step in here, or Mark have a further addition?
Yeah, I'm not aware of any studies that have followed an individual child over years at a time, or yeah.
So to me, it represents a particular powerfulness of those seasonal distributions, that you can detect seasonality across the population.
Yeah, I agree. Yeah.
Another question is, the person asks, just curious, what explains the drop in the Flint values while the water was still being used? the figures seem to show after the highest peak, well above the statewide peak, that the Flint number dropped and was coincident with the statewide data before rising once again.
Let's see, let's see here. Let me look at that plot.
This was the green line, I believe, for Flint. There it is.
Okay. So you're saying that this right here, it comes back to, so what was the question again?
Yeah, the question was basically, why does the green blood lead in Q3 there for those 2 years exceeding the statewide average, and then in the dormant season in the wintertime, it actually returned to, even less than the statewide average.
Yeah. Well, I'd assume that the reason it exceeds is because there's a high input of lead from the pipes.
Yep.
And I'm guessing that, we do know that pipes do release lead seasonally. This has been shown in Canada and in Washington, D.C. So it could be that you had the temperature had something to do with this peak in the third quarter for Flint. But as you went back to this time period in the winter, it became cold again and you didn't have as much release of lead from the pipes. I'm just speculating.
Yeah.
Yeah.
There were a couple of questions along those same lines.
I'm not sure.
Yeah. So being able to say, I don't know is a strength of being a good scientist, Mark.
Yeah.
Let's see, that came up in a couple of questions. So we'll have to all look into that. I was unaware that lead in that there may be a seasonality to lead in solution, as you mentioned, from Canada.
Yeah, there was there's a study in I think it was in Montreal where they showed that some of the lead levels in the water were higher in the summertime. And there's, and another study in Washington, D.C. showed a seasonality with the lead in the water.
Very good.
Yeah.
We'll look into that. Another question is, could you repeat and explain why you feel that the recent London study is a sort of vindication of your work that you've written about in many papers?
Okay. Let me get back to this. Okay. In our 2012 paper, we showed that soil lead concentrations or atmospheric lead concentrations and atmospheric soil concentrations were highest during the weekdays and lower during the weekends and public holidays. Now, this is exactly what they found in London. You can see it right here on this chart, where Monday through Friday, you've got much higher elevated lead and silica, which is a proxy for soil. And on Saturday and Sunday, you have much lower concentrations. So that suggests to me that because it's traffic related, and we also found that in this chart right here, yeah, these all showed peaks in the summertime of soil and lead in these four cities. And yeah, so I'm losing my train of thought. I'm nervous. So in these cities, you know, it's also found that the weekday is much higher than the weekend. So it seems to be driven by soil resuspension, which suggests to me that these peaks are ultimately being driven by soil resuspension by the roadside, where you have all the lead contaminated soil. I mean, it's possible. I can't prove it, but it just seems to me that that could be the case.
Yeah.
So.
And then and the London study also adds the isotopic evidence from gas derived lead, which is another key piece of evidence. Another interesting question is a focus of the presentation was on the role of atmospheric lead and blood lead. Wouldn't direct exposure with soils, dermal adhesion, incidental ingestion also play a seasonal role in increased blood lead levels due to outdoor play activities during the summer, etc.?
Oh, that's a good question. Yeah, I think that would play a role as well. Although I wouldn't expect to see such smooth curves associated with just going outside and getting exposed to soil during play. But that's my thought on that.
Yeah, thank you. Another different kind of question. Any comments on the practice of mowing grasses along public highways, particularly in arid regions?
That's a really good question. I've often wondered, like, how exposed, like, people who do that for a profession, who cut lawn and get exposed to resuspended dust when they're near roadways, when they're cutting lawns, especially in the summertime. It would be an interesting study for somebody to do. I think, yeah, that's definitely a concern. I haven't heard of anybody who's done a study like that, though.
Yeah. And another question, which is a sign of a great talk, Mark, all these questions. Hi, I'm a reporter in Asheville, North Carolina. I am investigating elevated lead levels in fish in a local river downstream from two plants. One is an energy plant and the other a zinc hazardous metals recycling plant. Do you know of anyone studying the impact of metals on fish with some level of lead consumption? Don't exactly understand that, but what comes to mind?
Oh, I'm sorry. I don't have any experience in that area. I'm not familiar with that.
Right.
I couldn't answer that.
Yeah, thank you though for entertaining it. Next question is how long does it take for blood lead levels to increase after observing increased levels in air?
That's a good question. This data suggests that it's relatively rapid, but I don't know of any studies that have examined that exactly. So,
Yeah, it does seem like there's pretty fast turnaround, but it's not, these are not controlled experiments.
yeah.
So let's see here if I can find another one. Um, go over to chat here. Here's a different kind of question. I'm interested in consequences of lead exposure for adults and the elderly. Are the seasonality concerns mainly an issue for children who show hand-to-mouth behavior, for example, or will we expect the same blood-lead seasonality in adults and the elderly?
Oh, that's a really good question. I think that as you can see in some of these charts where they use children of different ages, there's a much different response. Like in the um, Detroit blood lead, I think we had children aged 6 to 11 and then 1 to 2, and there was a drastically different blood lead concentration seasonality. In terms of adults, I'm not aware of any studies in the United States that have examined blood lead seasonality in adults, but I wouldn't expect adults to be impacted due to because they're not they don't have the hand to mouth activity that children have.
Yeah, thank you, Mark.
Yeah.
Uh, I've gotten through what I did my best to get through all the questions. I might have accidentally missed one or two. And a couple of people whose questions you've answered describe them as very helpful. Let's see here. There was one I remember a second ago, if we can pardon me for going up in the chat. It was about a member of the audience from Dunedin. I think that's Dunedin, Florida. So
Okay.
this was a really terrific presentation, very compelling. This is motivating me to add soil lead mapping to our work in the Dunedin study on legacy lead and brain health. I guess that was a comment. So.
Oh, that's fantastic. I really appreciate it. And yeah, glad I could be of use to someone.
And it reminds me of the slogan of Anna Wade, which was, every city needs a soil lead map. if only for the purposes of environmental education. So
yeah, I think they should.
Please go ahead.
Yeah, go ahead. Oh, I was saying if you saw that soil lead map of London, the British took soil lead concentrations on a really high density grid across like 10 cities. And they've done a fantastic job. It would be really great if they could do that in the United States with the top 50 largest cities.
Yeah, that British Geological Survey is just about the study I know of with the greatest sophistication. That is amazing.
Yeah.
That they were able to do that. Well, thank you, Mark. It's great to talk to you and have you contribute to our monthly presentations here. I got another thank you from James Brown of the US EPA. He says, thank you, Mark. We enjoyed your talk. A number of EPA folks are on this webinar and thoroughly enjoyed the month. I must say, we all appreciated your passing us the new PNAS London study, and I immediately circulated that around, and there was a lot of demand for that paper. It's an important one, I think, in the bigger scheme of things. And I've gone ahead and invited the top couple of co-authors of that paper to a future presentation.
Oh,
So
fantastic.
I'll add you, Mark, to our mailing list each month, and maybe you can join us, even if it's midnight on some of the future calls.
Well, that would be fantastic.
Yeah, I want to thank the Duke Catalyst program that began this seminar, and I want to thank each and every participant. We got into the, I think we got into the 60s or 70s today, and let's all keep working on this problem, and see you next month.